All right, I'm going to turn the lights off. We are going to talk about series today, and so we're going to talk about series basics. We're going to talk about sigma notation. And the issue or the challenge today is that we don't know if these things are arithmetic or geometric, and that will be sort of the challenge. When we come back from break, we'll kind of split it up, and we'll talk about them separately and get some formulas. So today is kind of like doing things the long way. Just like when we started out with sequences, we sort of did things the long way without the formulas, and then we learned them. So that's like what's happening here. Did you guys get your stat box? All right, so we'll start off with some basic vocab. So a series is the sum of the terms in a sequence. So what we've been dealing with so far this chapter are just sequences, which are lists of numbers. But when we say the word series, series means we are going to add up that list of numbers. You might have a finite sequence, and then the sum will always be a finite real number. So if you are just going to look at the first 10 terms of a sequence, you can add up those 10 terms and get an actual number. Now for an infinite sequence, there's actually two different cases, and we'll look at this more in depth later on this chapter, but in an infinite sequence, when you try to add them all up, sometimes you're going to not get a real answer because you're adding up all the terms from the first term to infinity, which is kind of crazy, but sometimes actually adding those terms up sort of evens out and it does converge to a finite number. If that's not making sense, don't stress. We will talk about that in much more detail in section G, so don't worry about it. We're used to U sub n representing a term. If we have S sub n, that represents a series. So I kind of think of it as S, the series stands for sum. So when I'm adding them all up, I use S sub n to represent that sum. And then the last kind of bit of new stuff is sigma notation. So what we do is we use sigma notation to sort of write that series more compactly. So we will do a couple of examples where we just use kind of our normal notation with S sub n, and then we're going to do a couple of examples using sigma notation. Have you guys seen that symbol before for sigma? Not for sigma. What have you seen it for? I mean, it's a Greek letter, so I mean, if you ever watch a movie with like sororities and fraternities and stuff, like you might have seen it in there. Just saying, but yeah, it stands for like the sum. So I know it's kind of a funky symbol to get used to, but kind of practice that. I'm going to explain a little bit more about sigma notation on the next slide, because normally it's not just the symbol, there's some numbers and formulas that go along with it. Okay, so usually the sigma has a few numbers on it. The number on top, right now I have n, but the number on top is the last term in the series. So if you have a 5 on top, that means you're going to add up the first 5 terms. So you're going to stop at the 5th term. That's the last term. So it kind of tells you how many terms you're going to add, that last term. On the bottom of that sigma symbol, you'll see k equals a number. In this case, I wrote down number 1, but that's the term the series starts with. Now, in our examples, most of them are going to start with the first term. So you'll start with the first term, you have to figure out all the terms till you get to the last term and then add them up. But you might come across a series where they want you to start with the 10th term and add up terms 10 through 15. So they might have 10 down here and a 15 up there. So we'll talk a little bit more about that. And then after the sigma symbol, there is a formula, that general term, just like when we talked about the general term in 6b last week. You're going to have a little formula there that tells you how you can get the numbers in that sequence so that you can add them up for this series. So when working with this series, you need to figure out if it is arithmetic or geometric. That will be one of the maybe trickier things today, is it could be either or. And you need to look at it and decide, are we adding to get to our next term, or are we multiplying to get to our next term? Now, 6F and 6G will go into both separately, so when we come back from break, we're going to focus on just arithmetic series, and we'll get different formulas for the arithmetic series, and then when we get to 6G, we'll get different formulas for the geometric series. So we'll look at those in more detail. And like I said, today is kind of like the long way, so you can really understand the pieces of it, and then we will get some shortcuts, some formulas after break. So here is our first example. It's got two parts. We're going to write down an expression for S sub n, the series. And then we are going to find S sub 5. So that's the sum of the first 5 terms. So that's the sum of the first 5 terms. So that'll be the second part. So the series we have, the numbers in our series so far are 3, 10, 17, and 24. The first thing you have to do is figure out, is it arithmetic or is it geometric? So what do you guys think? Are we adding to get to the next term, or are we multiplying to get to the next term? We're adding, so it's arithmetic. So if you're really not sure, you could like take a number and subtract the number that comes before it to just check. Okay, so 10 minus 3 is 7, 17 minus 10 is 7, 24 minus 17 is 7. So you could do that to check if you want to. So that is our common difference. Because it's arithmetic, we have to go to our formula packets and take a look at our general term formula. So that general term formula was the first term plus n minus 1 times the common difference. So that's where you have to decide to use that formula. And that's where it like sometimes gets tricky, and that's where sometimes people get tricked out on like the test or quiz when it's all mixed together. It could be one formula or the other. You have to decide which one to use. Now that we have this, we can plug in the common difference. We can plug in our first term. That first term is 3. And after we simplify that, then we'll have finished part A. So then I've got 3 plus n minus 1 times 7. So I end up with 7n minus 4. So that is like my general term for this series. So that's really a lot like some stuff we've already done when we wrote general terms previously. Now to find the sum, that means we have to add up the first 5 terms. So there's really 2 different ways to approach it. I'm going to explain like the short way verbally, and then I'm going to actually do it the long way just so you guys get some practice with formulas. So the short way would be to keep adding 7. So what's our 5th term if we add 7 to 24? 31? So that's the easy way, right? And then that's 31, and then you add those all up. But just in case it might not be that easy, the other thing you can do is you can find the 5th term by plugging in 5. So 35 minus 4. Oh yeah, it is 31. Jerome was right. So I don't really care. I like to give you guys some practice, making sure you can use your formulas correctly. Then to find the sum, I have to add these all up. So I have to do 3 plus 10 plus 17 plus 24 plus 31. So these are like the first 5 terms. First term, second term, third term, fourth term, and 5th term. I'm adding up the first 5 terms to get my series. And I end up with 85. So that's for like part B. S sub 5 is 85. So we have to add all of those up, the first 5 terms. We're going to do another example with the exact same directions, but a different sequence or different series to take a look at. Are there any questions? Okay. Is that my phone? Okay. Remember to start off by deciding if it's arithmetic or geometric. Okay, so is this arithmetic or geometric? Geometric, absolutely. So remember, if you're not sure, you could try the subtracting way first. Okay, 2 minus 10 is 8, but 2/5 minus 2 is not 8. You guys see where I'm going with that? So I know it's not arithmetic because I don't have a common difference. So then you could try the dividing. Well, okay, 2 divided by 10 is 1/5. 2/5 divided by 2 will be 1/5. And you can use your calculator to help you out with that stuff. So my common ratio is actually 1/5. Especially, you know, when working with fractions, I say to have your calculator help you out. So don't just struggle or panic. Like, use your resources. So since we know it's geometric, I have to use the general term formula for a geometric sequence, which is u sub 1 times r to the n minus 1. So my first term and the first number in my list is 10. So I can go ahead and plug that in. So 10 times 1/5 to the n minus 1. That's it. Remember, these ones don't simplify as much as the arithmetic ones do. So you guys see, like, the big thing is deciding which formula to use, deciding if it's arithmetic or geometric. So then, just like before, we have to find the 5th term and then add them all up. So once again, I don't care if you take it the easy way and you times 2 25ths by 1/5, you can do that. Or I'm going to practice with the formula, like I said, just to get some practice. So plugging 5 in the n spot. So I have 1/5 to the 4th power. So if I do 1 to the power of 4, it's just 1. 5 to the power of 4, I believe, is 625. So I have 10 over 625. But if I divide those both by 5, I end up with 2 over 125. So once again, yeah, I did it the long way. It would have been a lot shorter just to multiply by 1/5. I don't care which way you do it. But then to find the sum, remember the s, not s sub n, s sub 5, that means the sum of the first 5 terms, I have to add 10 plus 2 plus 2/5 plus 2/25 plus 2/125 and add those all up. So it's the first term, second term, third term, fourth term, and fifth term all added together. And yes, it's possible to get common denominators and do this all by hand, but you know what, I'm going to recommend that you guys use the calculator for that. So I get 1,562 over 125, or about 12.5. We're going to hit up the stop box and then talk a little bit about sigma notation. Are there questions? Are there concerns? A lot of it is very similar, except for we're deciding if it's arithmetic or geometric on our own, and then, we have to add them all up for the series. So I think it's really critical that you have an idea in your own words of how to figure out if a sequence is arithmetic or geometric. So whatever that means to you, whatever you're going to do, if you're going to test by subtracting the terms first, and if that doesn't work, try dividing to see, okay, if it's not a common difference, maybe it's a common ratio. Maybe you're just going to use your intuition and look. Whatever it is, you need to be able to figure that out. So write that down for yourself there. You guys got it in you. You guys are doing way better than earlier today. You guys are calm. You're with me. I appreciate it. Merry Christmas. Yeah. Sorry. Yes. Always. And then we're actually going to see this, and we looked at this in section A, but we haven't looked at it really since. Sometimes it's neither, right? Sometimes you have funky situations, so we're going to look at that a little bit today too. So we actually, like I said, I'm shortening up and not doing all of the examples today. We're going to take a look at some sigma notation here. So I have sigma, and my formula for my general term is 2k minus 3. K equals 1 means I start with the first term, and 7 means that's the last term. Now the directions are to expand and evaluate. So expand actually means I want to see all those terms. I want to see the first, second, third, fourth, fifth, sixth, and seventh term. And evaluate is the answer you get once you add them all up. And so, again, we're kind of doing things the long way, and when we come back from break, we'll get a few formulas here. What I have to do is start figuring out these terms. So since it says I'm going to start with 1, I'm going to start by plugging in 1. So I've got 2 times 1 minus 3. What's 2 times 1 minus 3? I heard it out there, -1. All right, so then I have to go up from 1, I have to go to 2. So I have to do 2 times 2 minus 3. I'm actually going to scoot this down a second. So that's 4 minus 3 is 1. So then I have to do 2 times 3 minus 3. So 6 minus 3 is 3. You might start to see a pattern, but we're going to keep going. Am I going too fast with the computations, or are we okay? Now I got to plug in 4. So 2 times 4 minus 3 left 8 minus 3, which is 5. So then 2 times 5 minus 3 is 7. 2 times 6 minus 3 is 9. And 2 times 7 is 14. 14 minus 3 is 11. So this right here is like the expansion. That's like when we say expand. Wow, that went really crookedly downhill. But that's what we mean when the expand part of it is actually writing down all of those terms. Taking a look at this, is this arithmetic or geometric? Arithmetic. And so in the future, come after break, I'm going to give you a formula so that you won't have to write down all the terms to find the sum. Okay? Like you could write down like maybe the first like 3 or 4 terms, decide, okay, that's arithmetic, and use the formula. Like that's something you could do. But we're not there yet. After this, then we evaluate. So when we add those all up, what do you guys get? I got 35. So that's the answer when you evaluate. We are going to do one more with the sigma notation to get used to it. Are there any questions? Now, one thing you might see is, let's say it was something like this, still going to 7, still the same general term, but down here it said k equals 5. What that would mean was that we're only going to look at this from 5, 6, and 7. Like you would start at 5 and you would go till 7. Just in case you run across that, just that's what that means there. So then we would only add up these ones when we found that sum of this. So we would only have to add those. So just kind of keeping that in mind in case you see that somewhere. All right, last example before break. Same thing, expand and evaluate. My sigma notation, I'm still going to start with the first term, but I'm only going to the 5th term. And my general term is k times k minus 1. Alright, so we'll start the same way by plugging those in. So first I start with 1, so I have 1 times 1 minus 1. 1 minus 1 is 0, so that's just 0. Then I have to plug in 2 into both of those k spots. So 2 minus 1 is 1, 1 times 2 is 2. Plugging 3 in there, I end up with 2 times 3 is 6. Then I've got to plug 4 in there. So 4 minus 1 is 3. 3 times 4 is 12. 5 minus 1 is 4. 4 times 5 is 20. So that's the answer for the expansion when I expanded that. Now, is this one arithmetic or geometric? What do you guys think? Absolutely right. It's actually neither. So this would be one of those situations where we can't use one of our fancy formulas. It's just kind of a different type of sequence. Still sequence, we can still find the series. It's just a little bit different. Now, when we add all of these up, we end up with 40 for the evaluation. So what do you guys think? Think you can handle series so far? All right. The assignment's not terribly long, so you can probably get a good chunk of that done today. Remember, if you have anything done that's not due, like D2, D3, or E, and you want to check it in before break, you are more than welcome to do that as well. And there is our 6E assignment.